Imagine looking at a galaxy that you can barely see, not because it is far away, not because it is hidden behind dust, but because almost everything inside it is completely invisible. A galaxy made almost entirely of something that does not emit light, does not reflect light, and cannot be seen by any telescope. Something known as dark matter. For decades, astronomers have known that dark matter exists. It surrounds galaxies, shapes the structure of the universe, and holds enormous cosmic systems together. Yet strangely, we have never actually seen it. Dark matter does not glow. It does not shine like stars. It does not scatter light like gas clouds. Instead, it reveals itself only through its gravitational influence. Recently, astronomers reported the discovery of something extraordinary, the galaxy that appears to be composed almost entirely of dark matter, a galaxy where nearly 99% of its total mass is invisible. Only a tiny fraction of its material consists of normal matter, the kind of matter that forms stars, planets, gas, and dust. In other words, this galaxy is almost completely dark. Discoveries like this are extremely important because they help scientists understand one of the greatest mysteries in modern astrophysics. What exactly is dark matter? To appreciate how strange this discovery is, we first need to understand what galaxies are normally made of. A typical galaxy, such as our home galaxy, the Milky Way galaxy, contains hundreds of billions of stars. These stars shine brightly across the universe. Between them are enormous clouds of gas and dust, where new stars are constantly forming. There are also planets, asteroids, comets, and countless other objects orbiting these stars. All of this material is known as ordinary matter, sometimes called baryonic matter. It is made from atoms, the same atoms that make up everything on Earth. However, when astronomers began carefully measuring the motion of stars and galaxies during the 20th century, they discovered something deeply puzzling. The stars were moving far too fast. According to the known laws of gravity, galaxies should not be able to hold themselves together if they contained only the visible matter we could observe. The outer stars should simply fly away into space. But they do not. Instead, galaxies remain stable for billions of years. Something invisible must be providing additional gravitational pull, something far more massive than all the stars combined. This mysterious substance became known as dark matter. The first strong evidence for dark matter came from the work of the astronomer Vera Rubin in the 1970s. Rubin studied how stars move within spiral galaxies. She expected that stars farther from the center would orbit more slowly, much like planets in our solar system. But that is not what she found. Instead, stars far from the galactic center were moving just as fast as stars much closer to the core. This could only happen if galaxies were embedded in enormous halos of invisible mass. Since then, dark matter has become one of the central concepts of modern cosmology. Scientists now believe that dark matter makes up about 85% of all matter in the universe. In fact, the visible matter we see, stars, planets, galaxies, and even ourselves, represents only a small fraction of the cosmic inventory. The rest is hidden, invisible, yet everywhere. Dark matter forms enormous halos surrounding galaxies and galaxy clusters. These halos act like gravitational scaffolding, holding cosmic structures together. Without dark matter, galaxies might never have formed at all. But the newly discovered galaxy takes this mystery to an entirely new level. Most galaxies contain a mixture of ordinary matter and dark matter. Typically, the visible stars and gas make up a noticeable portion of the galaxy's mass. However, in this unusual galaxy, astronomers have found almost no visible material at all. There are only a few faint stars scattered through the system. Everything else appears to be dominated by dark matter. It is almost as if we are looking at the shadow of a galaxy rather than the galaxy itself. To detect such an object, astronomers must rely on indirect observations. They measure how the few visible stars move through the system. By analyzing their motion, scientists can estimate the total gravitational mass of the galaxy. When they perform this calculation, they find something astonishing. The galaxy contains far more mass than the visible stars could possibly explain. In fact, roughly 99% of the galaxy appears to consist of dark matter. This makes it one of the darkest galaxies ever discovered. And discoveries like this provide valuable clues about the true nature of dark matter. Because if dark matter can form galaxies almost entirely on its own, then it must play a fundamental role in shaping the universe. Yet despite decades of research, scientists still do not know what dark matter actually is. It could be made of entirely new particles that have never been detected on Earth. Some theories suggest exotic particles known as WIMPs, or weakly interacting massive particles. Others propose particles called axions, which would be incredibly light yet extremely abundant. Experiments around the world are searching for these particles using highly sensitive detectors buried deep underground. These detectors are designed to observe extremely rare interactions between dark matter particles and ordinary matter. So far, the results remain inconclusive. Dark matter continues to evade direct detection, but astronomers are gathering more and more evidence of its existence by studying the structure of the universe itself. Observations from missions such as the Hubble Space Telescope and research conducted by organizations like NASA have revealed that dark matter influences everything from the formation of galaxies to the evolution of the largest structures in the cosmos. The discovery of a galaxy that is almost entirely made of dark matter offers a rare opportunity to study this mysterious substance in isolation. Without many bright stars to complicate the picture, astronomers can observe how dark matter behaves more directly. It is almost like finding a laboratory in space dedicated to one of the greatest unsolved mysteries of physics. And what scientists learn from such galaxies may eventually help answer a profound question: what is most of the universe actually made of? And the deeper astronomers look into the universe, the stranger the picture becomes. Because galaxies dominated by dark matter challenge many of our traditional ideas about how galaxies form in the first place. In the conventional model of galaxy formation, dark matter plays a critical role. Shortly after the universe began during the Big Bang, tiny fluctuations in the density of matter began to grow under the influence of gravity. Regions that were slightly denser than their surroundings started attracting more and more matter over time. Dark matter, which interacts primarily through gravity, collapsed into vast halos long before ordinary matter did. These halos became the cosmic scaffolding of the universe. Later, ordinary matter of gas made mostly of hydrogen and helium fell into these dark matter halos. Over millions of years, that gas cooled and condensed. Eventually, the first stars were born. Those early stars gathered into galaxies, lighting up the universe. In this picture, dark matter provides the gravitational framework, while normal matter forms the visible structures we observe. But when astronomers discover a galaxy with almost no visible matter, the story becomes far more complicated. Why would a dark matter halo exist without forming many stars? What prevented the gas from collapsing and igniting into stellar light? There are several possible explanations. One idea is that this galaxy may have lost most of its gas very early in its history. Young galaxies can experience violent bursts of star formation known as starbursts. During these periods, massive stars form rapidly and then explode as supernovae. These enormous explosions release tremendous amounts of energy. In smaller galaxies, that energy can be powerful enough to push gas completely out of the galaxy. Once the gas is gone, star formation stops. The galaxy is left with only the stars that had already formed and the invisible halo of dark matter surrounding them. Another possibility is that the galaxy formed in an environment where gas was already scarce. Perhaps nearby galaxies or cosmic radiation stripped away the material needed to form stars. In that case, the dark matter halo would remain largely empty, almost like an invisible skeleton of a galaxy. There is also the possibility that such galaxies represent an early stage of cosmic evolution. Perhaps we are observing a system that never fully developed into a bright galaxy. Instead, it remained a faint and quiet structure dominated almost entirely by dark matter. Studying these unusual galaxies is extremely valuable for cosmologists, because they allow scientists to test their models of how the universe evolved over billions of years. If dark matter behaves differently than expected, it could force researchers to rethink some of their most fundamental theories. And there is another reason these discoveries are so important. They may help scientists finally understand the true nature of dark matter itself. For example, if dark matter particles interact with each other in subtle ways, those interactions could influence the shapes and structures of dark matter halos. Some theories suggest that dark matter particles might occasionally collide with one another. Others propose that dark matter may behave almost like an invisible fluid. Observations of galaxies dominated by dark matter can provide clues about these possibilities. If astronomers find patterns in how dark matter distributes itself in different galaxies, those patterns may reveal the underlying physics of this mysterious substance. Large observatories continue to search for more galaxies like this one. Future telescopes will expand this search dramatically. One of the most powerful instruments designed for exploring the large-scale structure of the universe is the Nancy Grace Roman Space Telescope, a mission led by NASA. This telescope will survey enormous regions of space, mapping millions of galaxies and helping scientists trace the distribution of dark matter across the cosmos. Another technique used to study dark matter is called gravitational lensing. According to the theory of general relativity, massive objects bend the fabric of space and time. When light from distant galaxies passes near a massive concentration of matter, its path becomes slightly distorted. Astronomers can measure these distortions and use them to map invisible mass. In many cases, gravitational lensing reveals enormous clouds of dark matter surrounding galaxies and galaxy clusters. Sometimes the lensing signal even exposes structures that contain almost no visible stars at all. In other words, dark matter leaves fingerprints across the universe, even though it cannot be seen directly. The galaxy that appears to be composed almost entirely of dark matter may therefore represent an extreme example of a much more common phenomenon. Perhaps there are many such galaxies scattered throughout the universe. Galaxies that exist almost entirely in darkness. Galaxies whose presence can only be detected through their gravitational effects. If that is true, then the universe may be filled with far more structure than we can actually observe with light alone. It is a humbling realization, because everything we see in the night sky, every star, every nebula, every glowing galaxy, represents only a tiny fraction of the matter that truly exists. The rest is hidden, silent, invisible, yet shaping the universe in profound ways. Understanding dark matter is therefore one of the most important challenges in modern science. It touches nearly every field of astrophysics and cosmology, from the formation of galaxies to the evolution of the universe itself. And discoveries like this mysterious dark galaxy bring us one step closer to solving that puzzle. Because sometimes, the best way to understand something invisible is to study the places where it dominates completely. And as scientists continue studying galaxies dominated by dark matter, an even more fascinating idea begins to emerge. What if there are entire regions of the universe where dark matter structures exist but almost no ordinary matter at all? In such regions, enormous dark matter halos could be drifting through space completely unnoticed. No stars, no glowing gas, no bright galaxies lighting up the darkness. Only vast, invisible structures detectable only through their gravitational influence. In fact, according to modern cosmological simulations, the universe may contain far more dark matter halos than visible galaxies. Computer models of cosmic evolution suggest that many dark matter structures never formed stars. These halos may simply remain dark forever. If that is true, then the visible universe we see with telescopes represents only the tip of a much larger cosmic iceberg. Beneath it lies an invisible network of dark matter structures spanning the entire cosmos. This network is sometimes called the cosmic web. It is a vast structure composed of enormous filaments of matter stretching across hundreds of millions of light years. Galaxies form along these filaments, gathering in clusters where the density of matter is highest. But most of the mass within this web is not visible. It is dark matter. Observations of the cosmic web have been made using powerful telescopes and large sky surveys. One of the most ambitious of these surveys was conducted by the Sloan Digital Sky Survey, which mapped millions of galaxies across large regions of the sky. By studying the distribution of galaxies, astronomers were able to reconstruct the underlying structure of the universe. What they found was breathtaking. Galaxies are not randomly scattered through space. Instead, they form enormous clusters connected by long filaments of matter. Between these filaments lie vast cosmic voids, enormous regions where very few galaxies exist, and threading through this entire structure is dark matter, invisible, but absolutely essential. The newly discovered galaxy that appears to consist almost entirely of dark matter may represent a small glimpse into this hidden cosmic architecture. It shows us that dark matter can dominate entire systems. It can shape galaxies. It can determine how matter moves across enormous distances. And yet we still do not know what it is made of. This mystery has inspired decades of research across multiple fields of science. Particle physicists have built massive underground detectors searching for dark matter particles passing through Earth. These experiments are often located deep beneath mountains or underground laboratories, shielded from cosmic radiation. The goal is to detect the extremely rare interactions between dark matter particles and normal matter. So far, no experiment has provided definitive evidence. But the search continues. Another approach involves high-energy particle accelerators, such as the Large Hadron Collider, operated by CERN. Scientists hope that collisions between particles at extremely high energies might create new particles that resemble the predicted properties of dark matter. If such particles were produced, they might escape the detectors unseen, leaving behind subtle signatures that researchers could analyze. Even so, dark matter remains elusive. It interacts so weakly with normal matter that detecting it directly may require technologies far more sensitive than anything currently available. Yet despite these challenges, the evidence for dark matter is overwhelming. Its gravitational influence can be seen in galaxies, galaxy clusters, and the large-scale structure of the universe. Even the afterglow of the early universe, known as the cosmic microwave background, carries the imprint of dark matter. Observations of this ancient radiation, measured by missions such as the Planck Space Observatory, have allowed cosmologists to estimate the precise composition of the universe. The results are astonishing. Ordinary matter, the atoms that form stars, planets, and people, makes up only about 5% of the universe. Dark matter accounts for roughly 27%, and the remaining majority consists of an even more mysterious component known as dark energy. In other words, the universe is mostly made of things we cannot see and do not fully understand. The discovery of the galaxy that is almost entirely composed of dark matter highlights just how dominant this invisible substance truly is. It reminds us that the bright stars we see in the night sky represent only a small part of the cosmic story. Most of the universe remains hidden. Yet slowly, through careful observation and patient research, scientists are beginning to reveal its secrets. Each new discovery brings us closer to answering one of the deepest questions in physics. What is the universe really made of? Perhaps the answer lies within galaxies like this one, faint, mysterious systems where dark matter reigns almost alone. Galaxies that glow only faintly with a handful of stars. Galaxies that exist mostly in darkness. And yet, through the quiet pull of gravity, they reveal the presence of one of the most important ingredients in the cosmos. A substance that has shaped the universe since the very beginning. A substance that surrounds every galaxy, including our own Milky Way galaxy. And perhaps, one day, scientists will finally understand what it truly is. Until then, the universe continues to whisper its secrets through the faint motions of distant stars. And hidden among those motions may lie the key to solving one of the greatest mysteries of modern science. And yet, despite all the evidence pointing toward the existence of dark matter, one question still remains at the heart of the mystery. What exactly is it? For nearly a century, astronomers and physicists have been trying to answer that question. They had proposed many different theories. Some suggest that dark matter is made of entirely new particles that have never been observed before. Others propose that it may consist of extremely light particles that behave more like waves than traditional matter. And a few scientists have even suggested that our understanding of gravity itself might need to be revised. One of the most widely discussed ideas involves particles known as WIMPs, short for weakly interacting massive particles. These hypothetical particles would have mass, which means they would produce gravitational effects. But they would interact so weakly with normal matter that they would pass through planets, stars, and even entire galaxies without leaving much trace. If WIMPs exist, billions of them could be passing through your body every second without you ever noticing. Another fascinating possibility involves particles called axions. These particles would be incredibly light, far lighter than electrons. But because they might exist in enormous numbers, they could still account for the missing mass of the universe. Detecting axions would require extremely sensitive experiments capable of measuring incredibly tiny signals. Around the world, physicists have built instruments designed specifically for this task. Some experiments attempt to convert axions into detectable photons inside powerful magnetic fields. Others search for the faint electromagnetic signatures that axions might produce. Yet so far, the results remain inconclusive. Dark matter continues to hide from direct detection. At the same time, astronomers are continuing to discover more unusual galaxies where dark matter appears to dominate almost completely. These galaxies act as natural laboratories. By observing how stars move within them, scientists can infer the shape and density of the surrounding dark matter halos. Some of these galaxies are extremely small and faint. They are known as ultra-diffuse galaxies. These strange systems can be as large as the Milky Way galaxy, yet they contain only a tiny fraction of its stars. Their sparse populations of stars drift slowly within enormous halos of dark matter. Other systems are known as dwarf spheroidal galaxies. These are small satellite galaxies that orbit larger galaxies like our own. Despite their small size, many dwarf galaxies appear to contain far more dark matter than visible matter. In some cases, dark matter may outnumber ordinary matter by factors of hundreds or even thousands. This makes dwarf galaxies some of the best places in the universe to search for clues about dark matter. Astronomers study the motion of their stars with extreme precision. If dark matter particles occasionally interact with one another, those interactions might leave subtle signatures in the structure of these galaxies. So far, the results seem to suggest that dark matter behaves in a remarkably simple way. It interacts through gravity and almost nothing else. That simplicity may explain why dark matter has remained hidden for so long. But there is another fascinating possibility. Some scientists have suggested that dark matter might form entire dark galaxies or galaxies that contain almost no stars at all. These systems would be nearly impossible to detect with traditional telescopes. Yet their gravitational influence could still affect nearby galaxies or distort the paths of light traveling across the universe. If dark galaxies are common, then the universe could contain vast numbers of invisible structures drifting silently through space. Entire galaxies made almost entirely of dark matter. The recently discovered galaxy that appears to consist of roughly 99% dark matter may represent a rare glimpse of this hidden population. It could be one of the clearest examples yet of a system where dark matter dominates completely. And studying such galaxies may eventually help scientists uncover the true identity of this mysterious substance. Because once we understand what dark matter is, we will understand something profound about the universe. We will know what most of the cosmos is made of. And that knowledge could transform our understanding of physics itself. It might reveal entirely new particles, new forces of nature, or even new dimensions of space. For now, however, dark matter remains one of the universe's greatest enigmas. We can see its effects everywhere, in the rotation of galaxies, in the motion of galaxy clusters, in the structure of the cosmic web, and in mysterious galaxies that glow only faintly with a handful of stars. Galaxies where darkness itself holds everything together. Yet despite all our telescopes, satellites, and experiments, the true nature of dark matter continues to evade us. Perhaps the answer lies hidden within galaxies like this one. Galaxies that appear almost entirely invisible. Galaxies where dark matter rules. And somewhere within that darkness may lie the key to understanding the unseen universe.